Hi, I'm Engr.Juniel. I'm here to report about projectile motion.
Projectile motion. Observe the athlete. Throwing a javelin, the javelin follows a curved path and lands on the surface of the earth. Such objects like javelin, which moves a longer path determined by gravity and air resistance, are called projectiles. The part followed by projectile is called trajectory. An object dropped from a height. An object thrown vertically upwards and object thrown obliquely upwards are examples of projectiles. In all these cases, for influence of air resistance is neglected. The velocity of the projectile varies from point to point. At each point, the velocity has components in the horizontal and vertical directions. The vertical component of velocity continuously changes due to the force of gravity. Thus, the horizontal motion is a uniform motion and the vertical motion is a uniformly accelerated motion. The magnitude of the vertical component is different at different points and is directed vertically downwards. Let us now analyze the motion of a projectile thrown obliquely. Let a body be projected from a point O with initial velocity. The projectile makes an angle theta with the horizontal axis. The velocity of the projectile at any point of the trajectory goes on changing both in magnitude and in direction. The velocity can be resolved into two rectangular components, v sub 0 cos theta along the x-axis and v sub 0 sin theta along y-axis. There is no acceleration in the horizontal direction. The vertical component of acceleration, ay, is equal to negative g. Substituting the value of a sub x and a sub y in equations 1 and 2 respectively. That is, the vertical component of velocity changes with the time. At the highest point, the v sub y becomes 0. Let us now find out the resultant velocity of the projectile at any instant. The resultant velocity v is equal to vector vx plus vector vy. The parallelogram law of vectors, v is equal to square root of vx squared plus vy squared. V is equal to square root of v0 cos theta whole squared plus v sub 0 sin theta minus gt whole squared. The direction of the projectile at any instant is given by the angle between the velocity vector and the horizontal. Tan theta is equal to Vy divided by Vx from the equation Vy is equal to V sub 0 sin theta minus Gt. It is clear that Vy decreases when t increases and becomes 0 at t. At this point, the velocity is only along the horizontal direction. With further increase in time, the vertical component of the velocity gradually increases in the downward direction till the particle strikes the ground.
Terminology used in projectile motion. Horizontal range.
Horizontal range. The distance from the projection to the point where the projectile strikes the horizontal plane is called the horizontal range. It is denoted by letter R.
Time of flight.
Time of flight of a projectile is the time taken by it from the instant when it is projected to the time when it strikes the point in a horizontal plane passing through the point of projection. T is equal to 2 v sub 0 sin theta divided by g.
Range of projectile.
Range of projectile is defined as the distance between the point of projection and the point where the trajectory cuts any plane. R is equal to v sub 0 square sin 2 theta divided by g. Maximum height. Maximum height is the maximum value of the vertical distance attained by a projectile above the horizontal plane to the point of projection in the figure. P is equal to point of maximum height. H is equal to V sub 0 squared sine squared theta divided by 2 times G.
Good day everyone, I will be discussing about the experiment projectile motion. So the first part is the zero angle. The given is the initial velocity is equal to 14 meters per second, while the gravity is 9.8 meters per second squared. So for our formula, for zero angle, the t is equal to the square root of 2 times height divided by gravity. The range is x is equal to initial velocity times time. This is the table which we got in finding the theoretical and experimental. I will be explaining it in the next slide. So the given is mass of the cannonball 17.60 kilograms, height is equal to 10 meters, gravity is 9.81 meters per second squared, initial velocity is 14 meters per second. So we will be just substituting it with the formula. So in T we will be getting 1.42 or 1.43. So for our range is equal to 19.98 or 19.99. So in getting the percentage difference, we will be equating theoretical minus experimental divided by theoretical plus experimental divided by 2 multiplied by 100. So for our percentage difference for time is equal to 0.15%, while the percentage difference for our range is equal to 0.00098. So the next part would be the zero height. So the formula is y is equal to the initial velocity times sine theta t or time minus 1 half g or gravity time squared. T is equal to 2 times the initial velocity sine theta over g. So this will be the table in finding the theoretical and experimental and also the percentage difference. I will be explaining it in the next slide. So solutions, the VO of y is equal to 14 times sine 25 is equal to 5.9. The VO of x is equal to 14 times cosine 25 is equal to 12.69. So y theta is equal to 5.9 times time minus 1 half times 9.8 times time squared. So we're in t is equal to 1.2 seconds, while the x theta is equal to 15.22 meters. So our percentage difference for time is equal to 0.83%, while the percentage difference of our range is equal to 0.54%. I just substituted it with the formula given, and the formula that I used in finding the zero angle. So that's all. Thank you.
What is the relation between the range and the height? The result suggests that an increasing in launch height causes an increase in range. Range depends upon two factors: horizontal velocity and airtime of the projectile.
Increasing the height means that the projectile has a greater vertical distance to travel. The upwards motion of the projectile is unchanged regardless of the height. However, the difference in range between each height occurs due to the increased or decreased downward distance the projectile must travel, which is the result of the launch height. Increasing the launch height increases the downward distance, giving the horizontal component of the velocity greater time to act upon the projectile and hence increasing the range. So projectile motion is a little more complicated than one-dimensional motion, but if we know how to divide any vector into x and y components, we can easily analyze projection motion as the combination of two types of one-dimensional motion.
However, the real purpose of the study of projectile motion is that it is a good way to practice and learn some aspects of general problem solving and understanding novel concepts in physics.
It helped tremendously that anybody can study the motion of a ball or a rock with some simple tools, a measuring tool, and a stopwatch along with a study partner. This makes it possible to learn that some physical phenomena have simple formula that describe them, and very importantly for future problem solving, that a wide range of problems can be understood through a few simple formula.
So aside from what is actually being studied on the surface about projectile motion, it serves to help teach students about generalizations about how concepts can be applied to a range of seemingly different problems, and about how some concepts of classical mechanics and some math too can be simplified to a handful of formulas that are then applied to each situation. This has been the experiment 3, projectile motion. This experiment, we were able to determine the relationship between the range and the height, and we were also able to calculate the theoretical and the experimental values of the experiment. Thank you so much, and God bless.